Good morning, everyone. I am Maitri Khazne and will be presenting on the topic Defending Against DDoS Attacks at Network Layer. So basically, this presentation will cover the basics of network security, the role of network layer, how DDoS attacks occur, and strategies to defend against them. Before we discuss about the DDoS attacks, let us understand the OSI model. It consists of 7 layers, each serving a specific function in the network communication. The network layer, which is our focus, is responsible for routing packets across different networks using IP addresses. This is where the most DDoS attacks occur. The network layer plays a crucial role in data transmission. It ensures that the data reaches the correct destination by determining the best possible route. Because of its role in packet forwarding, it is highly vulnerable to DDoS, that is distributed denial of service attacks, which aim to overwhelm the network resources. The network layer, these are the network layer functions. They are responsible for packet forwarding, ensuring that the data moves efficiently between devices using IP addressing and packet switching. It handles routing, selecting the best path for selecting its best path for data transmission, and subnetting, which organizes networks for better performance. It also manages error handling, which ensures lost or the corrupted packets that are retransmitted. Additionally, it supports multicasting and broadcasting. Multicasting means sending the data to specific groups, and broadcasting means sending the data to all devices. Most importantly, it ensures host to host delivery. That is, it makes sure data reaches the correct receiver across the networks. Since this layer controls traffic flow, it is a prime target for DDoS attacks, which flood it with excessive traffic to disrupt communication. Since the network layer plays such a crucial role in managing traffic, it can also become a prime target for cyber attacks. Attackers use DDoS techniques to flood this layer with excessive traffic, causing disruptions. Let us now explore how DDoS attacks affect the network layer and how we can defend against them. A distributed denial of service, that is DDoS attack, is a malicious attempt to disrupt a normal traffic of a targeted server by overwhelming the target or its surrounding infrastructure with a flood of internet traffic. DDoS attacks achieve effectiveness by utilizing multiple computer systems shown in the picture as sources of attack traffic. Machines can include computers and other network devices such as IoT devices. A DDoS attack is like an unexpected traffic jam clogging up the highway, preventing regular traffic from arriving its destination. This picture depicts it. So now, how do DDoS attacks works? A DDoS attack at the network layer is carried out using a botnet, which is a group of infected internet-connected devices, that is computers or uh, your IoT devices, etc., controlled remotely by an attacker. These infected devices are called as bots or zombies, receive instructions from the attacker to send massive amount of traffic to the target's IP address. As a result, the target's server or network gets overwhelmed, leading to slowdown or completely denial of service for the traffic. So, since each bot appears as a normal internet device, it becomes difficult to distinguish between malicious and legitimate traffic. Attackers often use techniques like ICMP floods, UDP floods, and SYN floods to exploit vulnerabilities in how data packets are processed, further disrupting the network operations. These attacks can cause financial losses and can impact critical services if not properly mitigated. A DDoS attack, how it can be identified? It can be identified when a website or a service suddenly becomes slow or unresponsive. However, since normal traffic surges can cause similar issues, further investigation can be needed. Some keys include like unusual traffic spikes from single IP address, multiple requests from a similar device or locations, and sudden uh, surges in the traffic to specific web page. Attack patterns may also appear unnatural, like repeated spikes at odd times. Using traffic analytic tools, we can distinguish between users and the attack traffic to detect the mitigate DDoS attacks effectively. For example, imagine an online shopping website running a big sale. Normally, during festive seasons, the website experiences a huge traffic spike, which is expected. However, if suddenly the website becomes extremely slow or crashes, and analytics show that most requests are coming from a single location, same device type, or one IP range, this could indicate a DDoS attack rather than real customers. Attackers might be using a botnet to flood the website with fake traffic, making it inaccessible for the real buyers. Without proper detection, the business could lose sales and customers. Now, these are the types of DDoS attacks at the network layer. There are two attacks: volume based attacks and protocol based attacks. Volume based attacks. These flood the network with excessive traffic to overwhelm the target. ICMP flood, that is also called as ping flood, sends a massive number of ping requests to overload the system. UDP flood overloads a server by sending a high volume or of fake UDP packets to random ports. TCP SYN flood, that is exploits the TCP handshake by sending continuous connection requests but never completing them, consuming server resources. For example, imagine a call center receiving thousands of fake calls at once, making it impossible for real customers to get through. This is similar to volume based attack, where an attacker floods a network with excessive traffic like ICMP, UDP, or SYN floods to block real users. Protocol based attacks. These exploit weaknesses in network protocols. The Smurf attack, which it is basically uses spoofed ICMP packets to amplify traffic, overwhelming the victim. For example, now think of a prank where someone spoofs your phone number and calls emergency services, making it seem like you made the call. This is like a Smurf attack, where an attacker sends fake request that gets amplified and flood the victim's system. Ping of death. It sends oversized ICMP packets, causing the system to crash. SYN reflection manipulates the TCP response process, forcing the server to send unnecessary replies, consuming its bandwidth. Another example is like sending an email with massive attachment that crashes your email app. This is similar to a ping of death attack, where attackers send oversized ICMP packets to crash a system. Moving forward, this is the impact of network layer DDoS attacks. Here, the DDoS attacks at the network layer can cause service downtime, making websites and critical services unavailable. They can also lead to bandwidth exhaustion, slowing down the internet connections and disrupting the users. The financial impact can be severe, with businesses losing up to $20,000 per minute due to downtime. Additionally, companies suffer reputational damage as frustrated customers lose trust in the service. Firewalls can also get overwhelmed, becoming a bottleneck instead of protecting the network. Here, if you want to give an example, it is like imagine an online banking platform facing a massive DDoS attack. Customers are unable to access their accounts, transactions fails, and the trust in the bank declines. The longer the attack lasts, the more financial losses and reputational damage occurs. Now talking about the how to defend against network layer DDoS attacks. To protect against DDoS attacks, various defensive strategies are used to filter out the traffic and maintain service availability. The first one is traffic filtering and rate limiting. This method blocks the excessive requests from a single source, preventing the network from being overwhelmed. It is effective against ICMP floods, UDP floods, and SYN flood attacks by ensuring only traffic passes through. For example, I'm sorry. For example, imagine a shopping website that limits the number of requests from a single user within a short period. If a bot tries to flood the site, it gets blocked, ensuring real customers can still access the service. Then the second one is firewalls and intrusion prevention systems, that is IPS. Firewalls block the traffic based on the predefined rules, while the IPS actively detects and prevents attacks in the real time. These tool helps defend against the packets and unauthorized access and protocol abuse. For example, a firewall acts like a security guard at a building entrance, allowing only the verified visitors. If an attacker tries to send a fake request, the firewall blocks them and before they reach the internet network. The third one is Anycast network routing. That is, this technique distributes incoming traffic across multiple geographically spread servers, reducing the impact of the attack. Instead of overwhelming a single server, traffic is spread out, preventing downtime. If here to give an example, a website uses multiple data centers worldwide. So a DDoS attack targeting one region won't bring down the entire site. The load is shared across the servers, ensuring continuous service. Next is the automated DDoS detection systems. These systems use AI and machine learning to analyze the traffic patterns and detect if any abnormal patterns are occurring in the real time. Suspicious traffic is blocked automatically before it can cause any harm. For example, a bank's online platform uses AI-based security that detects sudden spikes in login requests from unusual locations. If an attack is detected, the system immediately blocks the suspicious request, keeping the user safe. By implementing these defensive measures, organizations can mitigate DDoS attacks, ensuring network stability and service continuity. DDoS mitigation strategies. So basically, these are the four strategies I have mentioned here. So first one is the blacklisting and geo-blocking. It blocks the suspicious IP addresses or traffic from high-risk regions. For example, a website blocks a traffic from a country known for cyber attacks to prevent the threats. This is a very known example. Deep Packet Inspection, that is DPI, analyzes the data packets to detect and block the malicious traffic, that is suspicious traffic. Then the third one is the cloud-based DDoS protection. It uses external security providers to filter out the attack traffic before it reaches the network. For example, business routes traffic through a cloud service to block the malicious request. AI driven traffic monitoring. It is used to detect and prevent suspicious activities. For example, like unusual logins, those are blocked due to force attack. These techniques help prevent, detect, and mitigate DDoS attacks efficiently. Now, if talking about a case study, uh, the very renowned case study like Mirai botnet attack, which occurred in October 2016, it infected thousands of IoT devices like cameras and routers, using them to launch a massive DDoS attack. A major DNS provider on the major DNS provider. The attack disrupted major websites like Twitter, Netflix, and Amazon, making them inaccessible for hours. It highlighted the need for strong IoT security and better DDoS mitigation strategies. Example in simple terms, like imagine thousands of fake customers rushing into a shopping mall at once, blocking real customers from entering. Security guards must identify and remove the fake ones to restore the order. In conclusion, the network layer DDoS attacks pose a significant risk to modern businesses and services. A combination of firewalls, filtering, and AI driven security and cloud based protection also is essential for the defense. Organizations must also continuously monitor the traffic to detect and prevent such attacks before they cause damage. Thank you for your time.